A lunar eclipse occurs when the moon passes directly behind Earth and into its shadow. This can occur only when the Sun, Earth, and the Moon are aligned in exactly or very closely so, with the planet in between. Hence, a lunar eclipse can occur only on the night of a full moon. During a total lunar eclipse, the Moon first enters into the penumbra, or the outer part of Earth's shadow, where the shadow is still penetrated by some sunlight. The shadow cone of the Earth has two parts, a dark, inner umbra, surrounding by a lighter penumbra. The penumbra is the pale outer portion of the Earth's shadow. The Earth's penumbral shadow is so faint that it remains invisible until the Moon is deeply immersed in it. For about the next 40 minutes the full moon will continue to appear to shine normally, although with each passing minute it is progressing ever deeper into the Earth's outer shadow. Just before the moon begins to enter the Earth's dark umbral shadow, the penumbra should appear as an obvious smudge or tarnishing of the moon. The moon now begins to cross into the Earth's dark central shadow, called the umbra. A small dark scallop begins to appear on the moon. The umbra is much darker than the penumbra and fairly sharp-edged. As the minutes pass, the dark shadow appears to slowly creep across the moon's face. With 3/4 of the moon's disk now eclipsed, that part of it that is immersed in shadow should begin to very faintly light up, similar to a piece of iron heated to the point where it just begins to glow. It now becomes obvious that the umbral shadow is not complete darkness. Its outer portion is usually light enough to reveal lunar seas and craters, but the central part is much darker, and sometimes no surface features are recognizable. Colors in the umbra vary greatly from one eclipse to the next. Reds and grays usually predominate, but sometimes browns, blues and other tints are encountered. When the last of the moon enters the umbra, the total eclipse begins. Some eclipses are such a dark gray-black that the moon nearly vanishes from view. At other eclipses, the moon can glow a bright orange. The reason the moon can be seen at all when totally eclipsed is that sunlight is scattered and refracted around the edge of the Earth by our atmosphere. To an astronaut standing on the moon during totality, the sun would be hidden behind a dark Earth outlined by a brilliant red ring consisting of all the world's sunrises and sunsets. The total lunar eclipse starts once the moon is completely inside the umbra. And the moment of greatest eclipse happens with the moon is halfway through the umbra. Before the moon entered the Earth's shadow, the temperature on its sunlit surface hovered at 266 degrees Fahrenheit, 127 degrees Celsius. Since the moon lacks an atmosphere, there is no way that this heat could be retained from escaping into space as the shadow sweeps by. Now, in shadow, the temperature on the moon has dropped to -146 degrees Fahrenheit, 99 degrees below 0 Celsius. A drop of 412 degrees Fahrenheit, 226 degrees Celsius in just over an hour. The emergence of the moon from the shadow begins. The first small segment of the moon begins to reappear. Several minutes before and after totality, the contrast between the remaining pale yellow sliver and the ruddy brown coloration spread over the rest of the moons may produce a beautiful phenomenon known to some as the Japanese lantern effect, a term first coined by Long Island astrophotographer Peter Levens in the 1950s. Any vestiges of coloration within the umbra now disappear. From here on, as the dark shadow methodically creeps off the moon's disk, it appears black and featureless. As the last, faint shading vanishes off the moon, the visual show comes to an end. The eclipse officially ends, as the moon is completely free of the penumbral shadow. How does the man in the moon cut his hair? Eclipse it.